Hi, so here we're going to try and complete this Leetcode test, the symmetry test. And as we go and we see in the description, given two binary trees, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same values, or each node has the same value. So we can see the example 1, 2, 3, 1, 2, 3. We can tell just by looking at it that it's identical. And also looking at the array output, it's also identical. And then we have other examples where we have another example where we have the same number of nodes with the same values, but not in the same order. So the output array is different. And a third example where same structure, as you can see, as a tree, but then the values and same values, but not in the same order, same nodes, not in the same order. So it looks like to check that the two arrays are, the two trees are identical, we will need to traverse each tree and compare each nodes. And there's two ways I can think of to traverse a tree: depth first search and breadth first search. In this case, I would say that the simplest to implement is breadth first, depth first search, or one of them, because we can just implement it using a recursion. So if we try, actually, what thing I like to have is to add the test cases as provided here. So the arrays, so we can test them later. We can just, it's convenient that they're already passing, giving us some test cases. We don't need to think about ourselves. And of course, we need to think of a few more things that you're not mentioning. The usual one, which is empty arrays. And just to check for empty arrays. And I think they're covering enough. Trying to think what other case could be a valid one. I guess one would be that's really 1, 2. It wouldn't be. I was trying to think, just so you guys know, I was thinking of the 1, 2, 3. 1, 2, 3. I took a third here versus 1, 2, 3. But then there would be, it would actually be 1, 2, null, 3, null, null, or 3 null. It wouldn't be the same. So we don't need to think about this case. So if we try now and solve this issue, so we get this function signature, which takes 2 parameters. And what we're going to do is implement recursion and with 2 parameters as well. So every time we go from a node to another, and we'll pass a node from P and a node for Q. When it comes to doing recursions, I like to have helper function, and it's simpler to think about compute in my mind. So if we start with a function, this is console function. I'm using ES6 format, but use previous could use function, but I won't. And I call it st symmetry st recur. Double C1R, I believe. If it's not, then sorry guys. sorry, but in any case, I like to start with a recursive function that I will then call with the original values. So I'm not sure what I'm going to return yet, but I'm going to call it for sure. So st recur. Thank you. No, what's up? St recur. Okay, well, let's assume it's correct. I'm not sure why it's not highlighting, but it is the same. Yeah. Thanks. So what I would do then, as I said, so you take two trees, I guess. Click tree 1, tree 2. I could call them P and Q, but it's simpler to reason about. So what I could do, so these are actually nodes. I like to be verbose really when it comes to my variables, because then it's easier for me to think about. Another one, not one tree, sorry, the tree P and tree Q. What I would do with nodes, so I would compare those nodes, and I would return, I would compare the values of each node. So nodes dot val should equal q dot val dot val. I'm saying that why am I not typing dot val? So I'll return this value, and the other things I want to check is that if they are equal, so if they're not equal, then I want to return false. And if they are, then I would want to call first st recur recur of dot left and recur right. What would I do with these values? St recur value return false. I really want to do this way. I think I'm going to return true, and so I would check left and right if they do exist. And they are not undefined. So I will do this and this and this. I store them. It is left. right? I'm too fast, aren't I? That is right. Incorrectly as well. That is right. So let okay. Okay. Be the values of the current nodes. So I check children first and I check the current nodes last. And if all of these are correct, then I would return incorrect. What I'm writing here. I'll put some parentheses just to make it clearer, but should not need them. So what I would return? So I would return would return, so it is left and it is right and okay, return and my base condition would be if you're using the base recursion in your recursions, it was your code will never stop. So if val null and null return true. So do this. Go back and true. Okay, and this should do, should it? What do you want to know? That's okay, I want it to return true or false. I will return true. Return true or false. PQ. Let's see what happens when we run this code. One time error. Not repeated. True. Cannot read. And so their value, which will be null, but the nodes themselves, that's maybe. Okay, so if not node and node don't exist. If I run it now, one time error. Cannot read property left of null. And what we're doing already is that if this is null, so what I need to read property P. So if both don't exist, we return. If they do exist, and saying cannot read property null. Some tricky question here left. If you don't have a value, then What can we do now? Speed checking. If you don't have a left, that will be fine. If you return, it should be null, no? If left. I'm just confused now. So our algorithm should be kind of correct, but with some issues, as you can tell. So is let let's start from the top. So we start with a node. So 0, 0, and we check. One on the left, left, and looks at left as well. Alright, and I put the left of 2, which will be at the end of that tree. Remember that triangular. Okay, so I get 2, and I check for this left, and this left doesn't exist. So what? Because I'm gonna check. Okay, well, this left. And then let me check it. Okay, what can we do here? So we could check for the left and right, and if they're both null, which is what I was doing earlier, wasn't I? If they're both null, then what? They're both null, we're happy. Alright, so if left, so it's a humongous code, but let's try that. So if not left and not onto else, do the same thing from the right side. Hopefully she should work. So right, right. Okay. Let's try that. I'd be ashamed if it does not work. Probably won't in any case, but let's give this a go. One time error. Why is it again null? This is why I'm confused now. I'm quite confused. I'm passing. Thank you, thank you. No. Yes, I don't have node. I do have a node. I'm checking. Yes. Sure. If one of them does not exist, however, then in get another setting. Okay, let's do this. If not, let's try that. What am I doing? I want to return false because that's not okay. They both need to be Same. False. And code. One time error. Again. What's taking longer? Time error. I knew it. Expected JSON. That's not nice. Unexpected JSON. Not. Oops. Because of the code, maybe. This happens sometimes. Code in the yeah, finished. Best. That was not easy. Let's submit. Let's see what it says. Probably going to complain. Hopefully, I have no errors. No code. So it accepts it. Woo! That code does not look amazing. It passes. So let's see more details. Are we doing well in time-wise and space-wise? Hello. It's 20%. Woo! Sure, we can do better. And space capacity 21%. So we doing great actually. Not bad, despite all the errors we had. Let's go back. La 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 la. I don't think we do much better. But sometimes there's a solution. Why didn't look at the solution and just see that? Let me have a look again because I'm showing some time complexity. Space complexity was fine. We have to do very recursion. The time complexity could be better, and could be because we do all those checks. Let's see why. That's one test we would not need to check. If they're both null, return true. I think it's fine. All right, that was it, guys. See you next time.